Hello everyone, my name is Aida Sakina binti Kahiro, and in this video I will be presenting a case study for the subject of TMI6323 malware and intrusion detection. This class is under the instructor Mr. Teo Chuan Shin, and my course is Security Technology. So the outline of this case study is that we were giving two different images. One of the images is a genuine SMS received from a local bank, and the second figure is a fake SMS which has been received by the hacker to the victim. Now, as you can see in the image in the left, this is the fake SMS which have been received. It specifically outlines its text messages very similarly to what we would genuinely receive from our local banks, such as Maybank, UOB, and etc. So one of the tasks for this case study is to first, assuming that I am the hacker, explain in detail what is my plan in order to conduct this type of scam. So based on the two figures that have been given, one of a genuine SMS and the second one being of a spoofed SMS, we can come to the deduction that this type of attack is commonly referred to as phishing, or the other term being smishing, as it is as SMS phishing. So if I were to the hacker, I would first send a text message which is identical to the ones given by the local bank, as shown in the figure to your left. And then I would encourage the user to call the number that has been given in the text. For example, in the figure, it says, please call 03277 40563 immediately. Once the user is encouraged to call the number given in the text, I would take advantage of the panic that they are feeling. As you can see in the image, it states that a total of 1,360 Malaysian ringgit have been used or have been transacted from their bank account. Now, this is not a small sum of money. If it were a small sum of money, in most cases, people would not feel panicked. People would not immediately care. They would call the bank immediately and to freeze their account. But if it's a large sum of numbers, there is panic and fear instilled within the person itself, making their brains a bit more foggy and leading to more irrational decisions being made. Therefore, when the user is encouraged to call the number given in the text, that number is actually not genuine. So this number is one that is phished or created by the hackers itself. And the purpose of this is that there will be a known actor with a given script behind this number. Once that number is called, immediately they will act as a member of authority. And in this case of a local bank, they would act as customer service or someone who is working at the bank. They would play the role of the actor, and they would constantly reiterate that a large number of sums have been transacted. And in this specific case, it'd be 1,360 Malaysian ringgit. Now, throughout this entire time, the user themselves, the victims themselves, are being panicked, are having anxiety, not knowing what to do, because that is a large sum of money. At this time, I, as the hacker, would take advantage of these feelings and I would keep on reiterating there's nothing that from our bank we can do. What I can do is to instead um, connect your call to the nearest police district or the main police district located in the heart of Malaysia, which is in Kuala Lumpur. Now, from there on out, I would then be passing the line to the second actor. The second actor is very important because they would be playing the role as an authorized official. And in this case, it is a police officer. As a typical citizens, we are someone who is encouraged to trust our police officers. So therefore, the second actor's role is to obtain the personal information. And how can we obtain the personal information? One is verbally, but then the second one would be that we would encourage for them to make an anonymous report through a website. So this website is actually not a genuine website. It is a phishing website. And in that website, we would insert a .apk file. And in that .apk file, we would put a system or an algorithm which would allow keystrokes to be recorded. So anytime the user is filling up their personal information, such as their full name, their government identification card, also known as ICs, or even their bank card number, as well as the CVV, immediately, due to the layout, the UI of the website being identical to one that you would typically see, the user in the midst of panic would just fill it in immediately. Now, what would happen is that we as the hackers would take those sensitive information and infiltrate the victim's phone or mobile devices. And from there on out, we would take out probably any type of personal information that we could find. But since this is specifically for local banks, we would obviously infiltrate the local bank app that is located within their personal phones. And from there on out, we would use the personal information that have been obtained from the websites and take out any remaining money that may be in the bank account itself. So number two, the scenario would be as a security specialist. What are the countermeasures that I can offer or recommend to the public for the scam above? Number one, um, weakest link when it comes to phishing scams is human ourselves. It's due to the nature of phishing scams. They tend to manipulate human nature, and the best way to combat it is by implementing education-based solutions. What it means by education-based solutions is to offer workshops or to offer talks that are regularly hosted by the banks themselves, probably online or even coming to universities to host these talks. Now, it is also found that based off of research that when these education-based solutions, such as workshops, are being made more interactive, such as in a gamified environment, it helps the users or the listeners retain much better information in comparison to if we were to treat it as a traditional workshop. So that is something to be kept in mind. Secondly, the second measure of countermeasures that we would implement is the application of technologies such as authentication apps. So these authentication apps are crucial in order to identify, is this really the person who should be handling this app? Now, lastly, there should also be an installation of antivirus applications on personal apps. And with antivirus applications, this is the major mitigation in order to reduce the amount of malware that can be spread on the device itself. And it really reduces the impact of the malware itself by, I would say, 70 to 90%. Now, the third scenario is the question asks, how can banking apps be improved? And based off of surveys of local bank apps such as Maybank's May, as well as UOB's application, an integration of artificial intelligence into their services would be highly recommended. As a current, these bank apps usually will implement AI in their chatbots themselves. But with my idea is that banking apps should integrate these artificial intelligence in order to act as an anti-malware application. So if there are any red flags that are being triggered, these apps will immediately go into lockdown and no transactions can be conducted whatsoever. Now, moving on, here is the prototype code for question number two, in which I proposed a malware analyzer tool. And this tool was created using Python with the utilization of the SCI kit-learn library on Python. So this specific library hosts a lot of machine learning. And therefore, this code implements machine learning. And as you can see with the test data itself, I recreated one of the messages that have been given in the case study. And there is proactive mitigation that is being implemented within the code, where it checks if the message uses high urgency keywords such as immediately or urgent. And it also checks whether it contains unverified phone numbers or external domains. And then what action could it be taken by the UI itself? Now, here's the proposed framework. First of all, we would have data acquisition and preprocessing. So this is where the unstructured textual data, such as the SMS payload, are ingested. SMS payloads are basically what is contained within the data packet of the SMS itself. Now, then the system would apply natural language preprocessing techniques, which includes tokenizations and indicators of compromise, also known as IOCs, are isolated. Number two, reputation lookup layer is ingested, in which the extracted IOCs are then cross-referenced with reliable materials, and this just acts as a high-speed filter. Number three would be the machine learning classification, where the textual payloads are then routed to the ML classifier. Now, this can be used for semantic as well as internal analysis, and the preprocessed text is actually transformed into numerical matrix using a method called frequency inverse document frequency, or TF-IDF. Following that would be the intervention by the system. So this intervention is made if the payload is classified as malicious. If it is not classified as malicious, it would be assigned the binary value of 0. Now, in this case, the system will automatically trigger the provocative app intervention layer, which shifts the security parameters. And what this means is that no transactions can be made, or the screen would turn black. Now, in the final phase, the machine dictates the GUI response, where there are two expected outcomes: safe execution or provocative lockdown. Now, and the third question for the case study is, how can we propose a solution for the provocative banking solution based off of the image given? So what we are given is the review details of a transaction being made, and this is an unreliable transaction. So based off of the proposed solution previously, I would first, instead of having an approve button, I would first have a button that states we are checking for screen overlays. So screen overlays are typically just um, malicious malware that can be contained within the phone itself. If there is any instances it is being contained within the device itself, then this transaction would be rejected automatically. However, if all tests pass, then and only then would the approve button appear. Now, I have come to the end of my presentation. Thank you very much for listening.